For the example that is being treated, we are making the following consideration. The BIM families of indoor units from manufacturers that we have found are very different, and some of them have been modeled in a better way than others. Then, we are facing situations such as this example, where the links are incorrectly connected. In this case, the link is oriented inwards, so this indoor unit could not be connected since it could mean that the duct is placed inside the indoor unit. It is also possible to face a situation such as this one, where the link is placed behind a geometry. So if a duct or a plenum was connected here, we could see how the geometry could be overlapped, creating interferences problems. It is also important the system classification. Here we see the output air, and here the supply air. The plenum must be connected to the unit as supply air, so if there is no link configured as supply air in the indoor unit, it would not be possible to connect it to the plenum. If this one was the link where the plenum had to be connected, it could not be possible, since it is classified as exhaust air. As well, in some cases it is possible to find exhaust and return air links, but not supply air links or some other configurations. It is also possible, and it is the most common case, to have connectors which size don't correspond to a standard one, not corresponding exactly with the geometry. Then, the plenum dimensions will not coincide with those considered by other manufacturers' modelers. Therefore, it is necessary to firstly consider some standard dimensions, which are the plenum manufacturing ones, and so we'll see how some adjustment will have to be done. In the current example, we are doing a considerable adjustment, though in reality it will be a matter of centimeters or even millimeters in order to adjust it to the exact dimensions of the indoor unit. However, it is also possible to do the opposite, which is to adapt the indoor unit dimensions instead of the plenums. As an example, we are directly changing the direction of the connector, and it may be possible to resize it as well. We see that it has neither parameters nor dimensions associated. Then, it will be possible to link it to some parameters in order to have a parameterized model. As well, if the system classification had not been correctly associated, it could be necessary to assign it the right one. Nevertheless, in the current example we are adjusting the plenum instead of the indoor unit, since in order to explain the necessary adjustment for each manufacturer, each of them should provide their own instructions in order to handle their families. We are now starting by placing the plenum. Considering already introduced the air supply outlets, each of them for its corresponding zone, an indoor unit that will be the mechanical HVAC system, we are also considering that there is a fresh air unit plus here. First thing we need to do is to insert our plenum. The plenum will be selected according to the Airzone guidelines, choosing the model that corresponds to the HVAC unit which it's being connected to, and the number of zones. In this case we are considering 3 zones, and we are using a generic indoor unit instead of a compatible one. This way will also be useful in order to see what happens when the dimensions are not the exact ones. We are making a little change here and modifying its connections to see what happens when the connection is not the exactly correct one. To insert the plenum, let's suppose we are controlling a decking unit with 3 zones with a standard plenum. In this case we would need this family. Since it doesn't exist a types catalog, that is a txt file with the same name, it means that we can insert the families directly from the files browser. Otherwise, we should load the file from the same software in order to load all the types and select the one we need. In this case, this is not necessary, as we can directly drag and drop the plenum from the files browser to the software. Then, it is necessary to align the plenum so it coincides exactly with the supply and air connector of the indoor unit. It is very important to align these two connectors, both in height and plan view. We see that the connector is here, and the aligning plan that coincides with the connector is also here. In the plenum, there will also be both a connector and the plan that coincides with it. It is necessary to be careful with some plenum configurations, because by here there is another reference plan to align the ducts with the dampers. These two plans shall be very close, and sometimes it may be better to eventually modify the gap of the neck with respect to the side, in order to have the plan displaced, then relocate it and restore this gap. Since this is not the case, we are aligning the floor with the plenum neck. The plenum is getting adjusted always taking the neck as a reference, so the neck is not getting displaced. The plenum will only move when its dimensions or connectors type are modified. Once the plenum is aligned on floor projections, the same is being done in height projection. We are using a section to see that it is not correctly adjusted and to see whether this connector has any plan by means of which the plenum shall be aligned. As well, we see that there are 2 reference plans here, and we must be careful and know that this one is the damper reference plan and this one the neck reference plan. So we are now aligning the plenum with the indoor unit. Here is actually easier, since the placing plan of the plenum is exactly the neck center plan, as it is in the indoor unit. So the placing reference plan coincides with the air supplying connector. We are now connecting the plenum to the indoor unit. In order to do this, with no intermediate element, the connector must have exactly the same size. The connector may have the same size, but not necessarily the same geometry. In the current case, both in the indoor unit and in the plenum, the connector's size and the geometry coincide. We could change the connector size and keep the geometry, but then we could not know the used dimensions unless we access to the parameters. So, if the parameters of the plenum neck had to be changed, it is possible to do it instead of modifying the parameters of the indoor unit connector. In indoor units of most manufacturers, the neck geometry does not coincide exactly with the connector, and these do not coincide with the dimensions list for which the plenum has been conceived. Manufacturers have developed their BIM families in different ways, so unless it exists an agreement between all modelers, dimensions will be different. Nevertheless, because they have to coincide, in this case we are modifying the plenum, though the indoor unit could be adapted as well. If the plenum is being modified, the dimensions of the neck must be adjusted to the connector, and it has to be taken into account that this modification will affect every plenum of this type, though the actual plenum supplied by Airzone will not be modified. What is being done is just an adjustment for the Revit model. A good practice, if the neck dimensions are being changed, could be to change the name of the type, specifying that these are being modified for a concrete indoor unit. Having this indoor unit, let's say it's a Daikin, we are now creating for this plenum a new type, assigning the good dimensions to the neck so it can be adjusted to the indoor unit. We see here the dimensions of the indoor unit. These are the real dimensions of the connector, and we see how they do not coincide with those from the plenum. We are now duplicating this type and naming it differently. Where do we modify the neck size? In the plenum. It is only necessary to modify these dimensions, which are those corresponding to the neck. These are the size dimensions, these the gap dimensions, and in some cases it might be necessary to modify the fresh air connectors, which are oval shaped. Once a new type is created, we are modifying the dimensions so the neck has the correct ones. As this shown, when modifying the neck dimensions, the plenum is not displaced. If we needed to adjust the gaps when changing width and height, it could be done by means of the interior gap and the side gap. The usual will be to add or deduct the half of the difference that was added or deducted towards the original dimensions. In order to center the plenum, it would have to be displaced the distance resulting from the difference between the center of the unit and the center of the plenum. Then, to this gap we have to add 127.2. If the gap is 267.2, when deducting 127.2, it results 140, which could be the side gap to introduce in order to center the plenum with the reference to the unit. On high view, if needed, changes should be done. Nevertheless, in this case, it is not necessary. Once the plenum is correctly located, next step would be to create the systems. We are creating the systems by means of the following procedure. Starting by the closest to the electronics, dampers have been numbered as 1, 2, 3, and as well, closest fresh air inlet is number 1, and the farthest is number 2. We are creating the first system for the zone supplied by this outlet. It will be an air supply system and will be named Zone 1. For this outlet, we create another system and we name it Zone 2, as well as for the last one that is named Zone 3. Let's visualize them on the system's browser to check all the data. Now we are assigning the plenum to all these systems as equipment by means of the output connectors. We see how all these systems are below the plenum. Now we are creating a system composed by the plenum and the indoor unit. From the plenum we create an air supply system and call it fan coil plenum. The plenum still has two free connectors. In this case, we are selecting the air supply connector that will be linked to the air supply connector of the indoor unit, and we choose as machine the indoor unit. We observe how the plenum is below the indoor unit as the outlet are below the plenum. If a fresh air system was created, it is highly recommended to duplicate the already created system and rename it as fresh air. So a new fresh air system shall be created from the plenum. We see that two different classifications are created, where fresh air ventilation includes the plenum as outlet and the fresh air unit as machine. We are now creating the physical connections. First connection that has to be created is the one from the plenum to the indoor unit. If the alignment and the resizing of the connector have been correctly performed, both connectors must be categorized as air supply, but plenums must be in while indoor unit must be out. Once we confirm it, we'll see how the plenum will move, but not the indoor unit. To check that everything is working properly, we are making visible the disconnections so we can visualize how these two alerts are disappearing when we connect the plenum to the unit. We see how they disappear, so the connection is correct. We are now connecting them to the outlets physically, and we are doing it by directly drawing the ducts. Besides, we can check how, since the outlet's airflow were 500 cubic meters per hour, the plenum airflow is then 1500 cubic meters per hour. By selecting the plenum both in the system browser and in the plenum itself, it is shown the global airflow, which is the result of adding the individual airflows from the outlets. We are now seeing how the fresh air is treated. We see that the global airflow in the indoor unit is the result of adding the individual airflows from its outlets. We are now adding the fresh air. This means that each outlet airflow will be the addition of the airflow coming from the indoor unit and the airflow coming from the fresh air unit. Then, the fresh air unit airflow must be deducted from the indoor unit global airflow. Then, the fresh air flow is being specified directly on the plenum. Supposing there's 200 cubic meter per hour fresh air from connection 2, we see how the indoor unit global airflow is adapted to 1300 cubic meter per hour. Now we make the connection for the fresh air unit to the plenum by means of a duct. And here, the whole model can be observed. We see how the plenum includes the airflow values from the outlets, the fresh air airflow. We see that the indoor unit is making right calculations and that all of them appear on the system's browser. If we introduce here 300, then the other value is reduced to 1100. As well, if we change the fresh airflow from 200 to 300, then the inter-unit airflow will be reduced to 1000.